Hi there, pre-calcers. Time for lesson 9.2, graphs of polar equations. We want to start out today by just showing you how we can generate some graphs of these polar equations just by looking at some specific ordered pairs, and then we'll show you how you can use your graphing calculator to do that and things like that. Alright, so first of all, let's just take a look at this chart here. We'd like to graph r and theta, or r equals sine theta is what we're going to primarily be graphing here. And so I've made a little chart here that we'll kind of fill out and see if that can help us out. Again, the equation we're going to do is r equals the sine of theta. So just filling this out, we're just thinking about what the sine values are. Of course, the sine of 0, sine is your y values at 0. At pi over 6, the sine is going to be 0.5 or 1/2. At pi over 3, that sine is square root of 3 over 2, which I'm going to call about 0.87. At pi over 2, the sine is 1. This is coming from your circle chart or from memory, hopefully a little bit. At 2 pi over 3, we're back to that 0.87. 5 pi over 6 is over here, then we're at 0.5. At pi, we're back to 0. At 7 pi over 6, now we're going to be at negative 0.5. That'll give us a little bit better feel for how to graph those. So then our ordered pairs, I won't do every one of these. You can fill this out. But ordered pairs then, let's see, maybe I'll change colors for emphasis. So the r value is the same as what this sine theta is. So this one would be 0, 0. And the next one would be the r value, again, the same as the sine, so 0.5 and pi over 6 and 30 and so on and so forth. So basically, this will be your r value here, and then of course that's theta. Now let's just see what these look like when I plot some of these. And I'm going to say that my scale here, just so you can see this fairly easily, we're going to say that we're going to go 1, 2, 3, 4. So this is going to be like a 1 up there. So to get to 1 is going to be way up there. Alright, so 0, 0 of course would be here. 0.5 pi over 6 would be right about here, I suppose, right? 0.87, that's going to be getting close up to here about, I would say. And then of course at pi over 2 would be at 1, which is where this one is graphed. And then 2 pi over 3 is that almost 0.9 again. And then at 5 pi over 6 we're 2.5, then back to 0. Now when we start getting to this one right here, the 7 pi over 6, remember going in this direction would be a positive r value, but notice it goes negative, so really it's also graphed right here once again, like that. And so when we get to the angles that are down here in the third and fourth quadrants, they're just going to be graphed up here again because of the negative r value. So kind of tricky, but I think you can see what's going to happen here is when we graph this, sure enough, it's going to be a circle. And so I just wanted to show you where these points are generated from, that we can plot them individually to make ordered pairs like that. Now we won't do this too much. Most of the time we'll be referring to distance and using our graphing calculator and such. Now this is a really helpful chart that you can write in your notes, so you may want to pause the video and write this down a little bit. I'll try to draw some shapes over here on the right side too. Now we've seen one like this back in last lesson. When you have theta equals something, that's just going to produce a line, and again that line is just going to be a straight line shooting all the way through. A circle, we saw this one, r equals something. There's a few other formats here though for the circle, but of course we know what a circle looks like. Now the rows is a little bit interesting, and we'll see some of those, quite a few of those this chapter. Notice the format for those, and the number of petals is kind of determined by that number that's multiplied by the theta angle. So rows might look something like this actually. That would be like a 4-petal rose, but there could be any number depending on that combinations of A's and N's there. Now the cardioid looks almost like a circle, but it does kind of look like a little bit of a heart like that, kind of a heart-shaped thing. There's a little loop in there, so it looks more like a heart. The limison, that's how you pronounce that. Again, that looks kind of like that too. A limison might have more of a pronounced loop in there somehow. It might look like this sometimes, but notice quite similar to a cardioid, except for where the cardioid has the constant and that coefficient are the same value. Here with that limison, you can see that they're a little bit different. And spirals, they might look like you'd expect a spiral to look something like that. Notice the various forms we have of those. So, good to be familiar with those forms. You'll be able to access this chart, though, to refer back to them in this unit. Graphing calculator-wise, just wanted to point out a couple things here we might have mentioned in class. If you're graphing these things, the key thing is you need to be in this polar mode. So you want to make sure to change your calculator to polar mode. And immediately when you do that, and if you go to your window and go to your y equals, it'll look quite a lot different. First of all, the window, this may be kind of a good default value here. We would like this value, even though it's not on here, to be 0. So from 0 to 6.28, that's 0 to 6 pi. This value here, I think, is pi divided by 12 or 24. Your x minimum and maximum, your y minimums, maximums, I set them at -3 to 3. You might have to change those a little bit. Probably the biggest change is when you go to your y equals menu, you no longer see y, but you see r. And of course that makes sense if we're talking about polar coordinates. And then even when you put the x key, x won't show up anymore. That theta will show up. And I just graphed this first example here, 1 plus sine of theta. You can see what it looks like there. And we'll be able to do some nice polar graphing. One thing you'll be able to, or want to do, is not only be able to graph them, but also to identify the type of polar equation we have. And this one, when both the constant and the coefficient there are the same, this would be the cardioid, or kind of the heart-shaped figure. Alright, so that's a big thing in this lesson, is simply just to graph and classify these polar curves. Example we're going to look at, a little tricky. This is a system of equations, but it's a polar system. We like to solve it using both algebra and trig, and we're going to try to do this in radians, so theta is between 0 and 2 pi. So if you go ahead and graph it, notice what you get. It looks like it has maybe 3 solutions, one right here, one at the top, and one at the top. Unfortunately, we can't figure out those solutions by graphing. If you go to the second and calculate, where we used to do the intersect option, that's not there now when we're in polar form, so we just have to kind of grunt it out here a bit. So let's go ahead and do that. I'm going to try doing a little algebra here, and the algebra would be to say that 2 cosine 2 theta equals 2 sine of theta. Because if we want to find where they intersect, we might as well just set them equal to one another. Now, a little troublesome here because I have 2 different trig functions. Maybe I can help myself out right away, though, and cancel out these 2's. I can divide by 2 both sides, and that'll be good. That'll be helpful. So those are gone. Now, I have a cosine and a sine. We like to get the same function if possible. So I'm going to make a little substitution here, and this is one of those double angle ones. You might remember that the cosine had 3 different formulas for that. So here's what it is. One of them is 1 minus 2 sine squared theta equals cosine of 2 theta. So I'm going to do that. Now I'm just going to rearrange everything on the left side. At least I have everything with sines now, so I have 2 sine squared minus sine of theta plus 1 equals 0. I can hopefully now be able to factor that. I don't really like all those negative signs, so I think I'm going to change those. So this would be a positive a positive, and this will be a negative. I can do that just like multiplying by -1. Now I think I can factor this. This is going to be 2 sine theta minus 1 times the sine of theta plus 1. And of course that's going to equal 0. And when I set each of these parts equal to 0, remember that's one of the things we like to do when we factor. When I set each part equal to 0, I'm going to get that the sine of theta is positive 1/2, or the sine of theta equals -1. And I should be able to solve this fairly easily. Notice this is between 0 and 2 pi, so I'm not really restricted on my circle chart. It's not principal values like we learned about last time. So the two places where theta is 1/2 is pi over 6, or 30 degrees, and also 5 pi over 6, which is 150 degrees. And over here, where does theta equal 1? Well, of course, or excuse me, -1, that's going to be at 270 degrees, or 3 pi over 2. Now, I'm not done yet because remember, this is a system. I got to find the coordinates for these. So just very quickly, I'll show you how to do that. Maybe I should change colors here a bit. That might help. So if I have r equals 2 sine theta, that's the original equation up here, I can put in one of these angles that I just found. So let's put in the pi over 6 here. And so I get 2, and then the sine of pi over 6 is simply 0.5, or 1/2, so that's going to equal 1. So that tells us that one of the coordinates here for my solution will be 1 comma pi over 6. And it looks like that might indeed be one of our solutions, like right here perhaps. There's pi over 6, and that might be about 1 unit. I can do the same thing over here. There's another one that I would get by putting 5 pi over 6 in there, and that would once again be the same thing, 1 and 5 pi over 6. My third solution, that was this one over here. My third solution then, which is going to be way up here, you can pretty much tell what that's going to be, and but I could still solve it algebraically, or if I needed to, it's going to be -2 comma 3 pi over 2. So again, there's that 3 pi over 2, which would traditionally be down here, but the negative r value sends it in reverse way up there. Alright, these kind of are a bit tricky, but I think you'll be able to do quite well on these, and you'll enjoy graphing these polar equations on your calculator. Thanks for listening, everybody. We'll see you in class.